Hello, everyone. Welcome to the Web Platform Podcast. This is episode number 29, and today we're going to be talking about reactive extensions. So on our panel today, we have Rob Simpson from Capco, and we have Nick Niemeyer from New Relic, JavaScript agent engineer, sorry, and Danny Blue from Deloitte Digital, and our guest today is Matt, and I'm going to butcher your name, so I'll let you introduce yourself, but Matt works on a lot of the RX stuff at Microsoft, so we'll be talking a lot about that today.
Yep. Matt Podwysocki. That'll work just fine.
Matt P. Woohoo!
Yes, there you go. Matthew P is my alias at Microsoft, so it kind of works out nicely.
So welcome. Thank you for coming.
No, thank you. Thanks for having me.
This is the second time we've had to reschedule this because of just weird things that have been happening. But,
right.
So we appreciate you bearing with us.
Not a problem.
So we brought you on today, obviously, to talk about reactive extensions and Microsoft's Open Tech. So can you tell us about what Microsoft is doing in the open source world and reactive extensions and kind of what it's all about?
Sure. It's kind of an interesting time here at Microsoft, and it's kind of a great thing in the fact that Microsoft has fully embraced open source in many different ways. For example, .NET Core is moving all of its infrastructure, all of its code base over to GitHub. If you go to Microsoft.github.io, you'll find pretty much every single Microsoft open source project out there. It's a lot of them, trust me. And so it's a very interesting time when we go from a company 10 years ago of not sharing pretty much anything to anything that can be released, should be released, and is thrown out there pretty much immediately on GitHub. So you have the Roslyn compiler, you have TypeScript, you have WinJS, you have any number of these things that are just being thrown out there. And I'd like to say that RX was one of the the catalysts for doing so. Because we kind of pushed the envelope first to saying we're going to GitHub and we're going to release everything that we did. Basically, emptied out our entire internal repositories and just said, "All right, here you go, have at it, folks."
Awesome.
Yeah, that's really cool. What do you think prompted that? You just said Microsoft is a very historically has been a very bottled company, not releasing anything. So what do you think prompted them to throw all of this stuff out there?
I would say a number of things. Is that you're starting to see pretty much every language being open. You're starting to see that what Microsoft is getting back is actually fairly valuable in terms of patches in a relatively short amount of time versus waiting for Patch Tuesday. Suddenly they're getting instantaneous feedback. It's been one of the core problems is how do you get feedback as Microsoft? We would have this Connect site and you would file bugs, vote on them, etc. But ultimately that wasn't actually helping the bottom line of actually improving the code because the PM would have to prioritize it and so forth. Versus now when everyone else has eyes on the code and can contribute to actually fixing that in a much shorter time frame. So it's a lot better that way that more people can participate, more people can have eyes on the code, and quite honestly have a much more responsive turnaround time for fixing things for folks. I think that was a key catalyst there is realizing that we can't just have these monolithic revs of software, is that we have to be a little bit more agile in terms of how quickly we can release software out there to the world.
Yeah. So Matt, so since Microsoft has done that, what's the feedback been for it to be with everything being, or a lot of things being open sourced?
The feedback's been fairly good. We have you always have a number of complaints in terms of they're not listening to my particular feature, but it's been overall it's been great. I mean, I've gotten a lot of feedback, obviously, on the products that I run in particular or help run. But the reaction has been overall very good, where instantaneously .NET goes from 0 watchers to over 6,000 watchers in a relatively short time. Fsharp, the language, moved everything over there, and they've just been fantastic in terms of their turnaround for creating new releases of the compilers and the libraries and so forth. It's kind of just grew this whole ecosystem that didn't quite exist before.
So there's a lot of different repositories. I see the Cloud Programmability group at Microsoft, and I know there's Microsoft Open Tech on GitHub as well.
Yep.
So can you tell us what are the core libraries we should be looking at and why?
Okay. Well, first off, you obviously have the .NET libraries. MS Open Tech is basically a wholly owned subsidiary within Microsoft, and their whole mission is to work with open source projects and help them along the way in terms of assistance on working on Windows, contributing to Linux for Hyper-V, any number of those kinds of things where working with Docker, any number of those kinds of things, making sure that they work well with us, and partnering with folks. I mean, one of the biggest success stories, obviously, out of OpenTech was partnering with Joyent to add a core Windows developer to get libuv to be cross-platform, therefore Node to be cross-platform. So they've got their hands in any number of buckets, whether it's getting Redis to really work well on Windows, to Docker, to obviously the reactive extensions as well. So they have a lot of hands in a lot of different pots, but it's really cool to see an organization really dive in with head first into this world where trying to make a better world for everyone, making sure that open source is indeed democratized, meaning I can run it on my machine and you can run it on yours. Now, for example, for our libraries, we're partnered with MS Open Tech through the former Cloud Programmability group. It's now just the RX group. And we're basically partnered with them, so we're working with them to release open source as much as we possibly can. We have any number of libraries, from the reactive extensions for .NET, reactive extensions for .NET, for C++, for JavaScript, obviously, for Python, Ruby, you name it. We're throwing it out there, as well as some of our older projects. Where we were really ambitious, such as IL2JS, which was our attempt to basically, you could write a WinForms app or a Silverlight app and compile it down to JavaScript, because we would just be transforming the raw IL directly to JavaScript. But that was back in, say, 2005, 2006 timeframe, when the Ajax revolution was still new and people were kind of afraid of JavaScript. jQuery wasn't really a thing, so it was our bright ideas at the time that were fairly interesting that we just kind of threw out there. People still to this day want full support for that, and I'm like, it's really hard to keep up with the IL spec. Thank you. In fact, I'll just say, if you really like programming in C#, TypeScript is close enough.
Yeah, TypeScript is pretty amazing. I've been using it on a couple projects here.
Yeah, and we're using it as well. We ship, for example, on RxJS, we ship TypeScript bindings in conjunction with the community. We're writing a compiler right now in TypeScript so that you can take expression trees and then compile it down to to Rx. So, for example, it opens up any number of things, any number of possibilities, such as sending things over WebSockets, queries over WebSockets, etc.
So why would I use RxJS or any of these reactive extensions?
Okay. Well,
And also explain exactly what we've said reactive extensions quite a few times. Explain exactly what
Yeah,
reactive extensions are.
okay,
good call.
sure. So I'll give you a little bit of history, and then it'll probably make a little bit more sense. So back when I was talking about the IL2JS days, what we were trying to do is trying to do automatic tier splitting of applications. So we could say part of your app runs in JavaScript, part of it runs in C#, and all you had to do was really put an attribute on it. But there are a number of issues that we would have there, such as, well, events aren't really compositional, and how do you really just serialize a callback over over the wire? There really wasn't such a thing. So there was really no composition of all of events at all. So we were like, oh, shoot, how are we going to do this? So we went through the Gang of Four book and said, oh, well, we have the subject observer pattern, right? This is fairly interesting. But it doesn't quite fit our needs because the subject observer pattern is basically the same thing of any old event listener as you find it today in JavaScript. You have add event listener and remove event listener. So what we did is we took a slight spin on that and said, well, let's move the actual subscription logic into the object itself. So whenever you call subscribe, suddenly that logic comes in. But anyways, the idea was to get fully compositional first-class, asynchronous, and event-based objects so that we could talk on both sides basically in the same kind of language, as it were. And that enabled any number of scenarios. So now you can reason about events just as you would with collections. We called it, originally it was called LINQ to events, and it kind of made sense because we had LINQ to objects, LINQ to SQL, etc., which is language integrated query. And we're like, well, LINQ to events just kind of makes sense, where we can treat events just as we would arrays, for example. Which is great for composition and great for resource management and so forth. So we were plugging away on that, and back in 2010 we came out with our first version. And the core of it is really we have the core idea that we're trying to solve is first-class asynchronous programming, because dealing with callbacks and dealing with events is problematic. You know, we designed this before promises were really a thing, and there really still is no great solution for dealing with first-class events. So coming at it from that angle, we were like, okay, let's create this library and see what we can do. And so we kind of have three parts to this. We have the observable, which is the producer of the stream, as it were. We have the observer, which is obviously listens to the values or is the consumer. And then we have this kind of this weird third layer that we think kind of is the special sauce, as it were, of Rx, which is the notion of schedulers, which is the how, what, where, and when do these particular queries run. And that's particularly interesting on JavaScript because you have any number of asynchronous mechanisms, whether it's set timeout, set immediate, process next tick, request animation frame, any number of those kinds of things that you want to kind of take advantage of, you know, as well as message channel, post message, etc., to kind of execute everything on your behalf behind the scenes without you having to get your hands dirty with all of those asynchronous primitives, as it were. And because we abstracted away that how, what, and when notion, that really kind of opened it up for easy testing, because now we could virtualize the time, as it were, and record everything as it happens. So if you look at our unit tests, everything we have is perfectly deterministic. There should be no async tests at all, or not many, rather. There are some, obviously, but the majority of it is we are deterministically testing when things go through they come out at a specific timestamp with a particular value, which is really, really valuable when you're dealing with asynchronous programming, when you're really wanting to know the order of things as they come out. So that's really kind of the genesis. It's those three core parts that well, sorry, the second part, I guess I forgot to mention, was more of along the lines of the composition piece, which is your map, filters, reduce, etc. Everything that you know on array extras that's shipped in ES5. You get for free in RX, so you could literally take the same code that you wrote for an array, and then just change the array source to an observable, and you would get the same darn effect. Except the difference is that instead of dealing with a deterministic pool-based mechanism, which are arrays, which you call the index, or upcoming you call symbol iterator and you call next. Here we have it more of a push-based, as it were. So we're kind of the exact opposite of arrays, where arrays are pool, arrays, sets, maps, etc. are pool-based, and we are push-based. And that's not necessarily to say that it's asynchronous, because by default RX is actually synchronous. People get thrown off by that. They're like, wait a second, I thought you were asynchronous. Well, not by default, no. It's only when you introduce time or events or anything like that that it becomes asynchronous.
Now, as far as that goes, you talked about promises just a bit ago too, and they weren't around back then, and there was crazy debates, I remember, back and forth. And finally, though, the next version of Internet Explorer and probably Spartan as well is going to have promises native, and we have promises in a lot of the other evergreen browsers. How do you see RX working with promises then in async, or even promises and generators?
Okay, well, I mean, first of all, RX has been first and foremost to fully embrace promises, because they are ubiquitous and they are fairly uniform in shape, whether you're using Q, whether you're using RSVP, etc. Versus the promises that will ship as part of the JavaScript runtime. They're all pretty uniform, and what's great is the fact that we can now treat promises also as observables. So, for example, in many of our operators that we have, such as concat, such as merge, etc., fully accept promises as part of as one of the parameters. So we treat promises just as we would treat observables, in the fact that they're first-class asynchronous values, which is cool to me.
Yeah.
And so that's a really great thing. The downside of at least the ES6 or JavaScript, ES 2015, JavaScript 2015, whatever we want to call it, is the fact that they don't have, say, deterministic cancelability. And what does that mean? So, for example, let's look at an autocomplete example for just to be interesting here. Is that when you're typing in real fast and then you send out a query via using a promise, there is no real mechanism inside the promise itself to say, disregard this value, I'm not really interested. Yes, there are patterns and libraries to get around that, but core intrinsically to the thing itself, there are no cancelability. And what does cancelability mean for that? And the difference between that and RX, in fact, all the way down to the core of schedulers, has deterministic disposal, as it were. So, to say, for example, you're creating drag and drop, or you're merging a bunch of streams together, that can be fairly expensive. When you unsubscribe, or when the system says it's done, all of those handles are automatically released for you. So you don't have to remember the remove event listeners or anything like that. That's automatically taken care of for you. So that to me is one of the true differentiators of these reactive libraries versus promises and so forth is the deterministic cleanup that you get from it. And that's key when you're dealing with complex user interfaces such as Netflix, where they don't really have to unsubscribe from events; they just kind of happen automatically for them. But to compare that with generators, well, once again, generators are just sequences as well, and once again, RX fully supports generators as well. Now, if you compare and contrast that with CSP or communicating sequential processes, which tends to be a hot topic as of late, it's fine in terms of a pub-sub kind of model, but once again, it's a very, very low-level asynchronous model, and they lack that deterministic cleanup that I was just talking about.
And when you say CSP, you're talking about content security policy?
Yeah, right.
Okay.
No, communicating sequential processes. Everyone likes to rebrand things, as it were, to their particular acronym, which is kind of ridiculous. But it is what it is. So there are tons of these new libraries that are coming out.
So Matt, let me ask you. I'm looking over the RxJS. So and I see a number of extras for RxJS. I hope I didn't miss anything, but without having these extras, what does RxJS come with out of the box?
Okay, well, it depends on which library you pick. We were kind of a mad scientist lab, as it were, when we started out. Like we were saying, we were doing IL2JS and so forth. What I recommend people starting out with is RX Lite, which is the idea is it has the most common operators that you're going to use on a daily basis. It's going to have your maps, your filters, your reduces, your concats and merge, take until, skip until, and some time-based operators such as interval and so forth that are pretty useful for games and so forth. So if you actually take a look at many of our examples that we have in our libraries, I recommend that people start there to start out with, because it's the smallest size and with the biggest punch, as it were. Else, it's just basically separated by kind of functionality, as it were, because we have so many different ideas kind of jammed into one, whether it's join calculus, whether it's coincidence-based concurrency, such as joins and group joins and so forth, to anything dealing with time-based operations versus anything to deal with virtual time, to deal with testing, etc., are all kind of just spread out. And the reason why is because I just didn't want this big monolithic thing. I just wanted it to be more of a bizarre model of, pick what you need. And to that extent, we also have a command line interface, which also allows you to build what you need. But I would recommend that most people just start out with the lights thing and then just sprinkle in what they need after that. Else, you can pull in the whole thing using RX all, and then just decide later what you're actually using.
Now, with that said, too, what's the interoperability? Do we have to worry if we're incorporating this into an Angular app or something that it's going to interfere with that?
No, that's actually a good point. Is what we strived for from day one is that we don't want to kind of take over the entire thing. What we do is basically build bridges, as it were, from events and so forth. So we have a lot of projects that we ship, such as RX, RX jQuery, RX Angular. There's RX Ember out there. There's even X. Sencha, basically RX Sencha. There's RX Dojo. as well as just the straight up RX DOM. So it's basically building a bridge to the DOM APIs, such as request animation frame, whether it's mutation observers or geolocation APIs, to Ajax and so forth. Basically, yes, I wrote my own Ajax stack.
Fun.
Yeah, absolutely. It's a laugh a second, trust me. But the interesting part is people are actually using that in production. For example, Office 365 and Office Delve are both using that right now in production, using my Ajax stack, which is kind of interesting but yet scary at the same point. But no, it's the intention is to augment what you're already doing, instead of replace what you do.
That's great, though. It puts it to the test, right? You have all these users on there, and you get to see what breaks, so you can fix it.
Absolutely, and there's a great community around React and RX, for example. There are a lot of people that think that Flux doesn't go far enough, and that RX is kind of a better answer for really the composability, event aggregation, and so forth than Flux is. So we have a lot of examples of that using Flux and not Flux, but RX and React together. So once again, we don't go out there to say we're the end-all be-all framework. We're just there to say that use what you're comfortable with, and then when you need us, we're there.
Yeah, it struck me as on the CodePlex site, it had mentioned that simply put, RX equals observables plus LINQ queries and schedulers.
Yeah.
And it occurred to me that the schedulers seemed much like the dispatcher in React, and the observables much like the data stores, right?
Yep, exactly. And then every time that you see something in one of those like to-do MVC examples, which we have listed off of our GitHub repo, it has exactly that. Is the stores are subjects, as it were, which is a combination of observer and observable all into one thing. So you can publish to it and you can subscribe to the same thing. So yeah, people are absolutely using that, which is really, really cool to see. And once again, you get the deterministic behavior that you want. You get fairly decent performance out of it, etc. So it's a win all the way around, I think. That people are really embracing it. And then you have others who are don't like React that much and want to create their own version of the virtual DOM plus RX to equal React and Flux. So called Cycle. So a lot of interesting stuff going on there.
To create your own virtual DOM, I don't think I'd want to do that. Like, just use what's out there, battle tested.
Well, no. They are using the virtual DOM. It's just the framework that encompasses RX and the virtual DOM together, as it were.
I see. Okay.
So on the site, I see that I am a book lover, and I see this Intro to RX book, and I see the publication date of 2012. Is that still a good book to read in regards to being up to date, or?
That's a good question. Lee Campbell has done a wonderful job there, and that was mostly based upon our earlier 1.x version, and we're on the 2. Something version. And the core concepts still apply, but we've gone well out of our way to create really good documentation to get started, hopefully. So if you go into our documentation, we have ways to get started. We have many tutorials. We have kind of how-tos, as it were, as well as our design documentation says here's how we approach designing all of RX all together. There are some people that put together a Git book, basically. Of taking all of my documentation and shoving it into book form, which has been great as well. And we're working on a total, as it were, a total RX family site. So RX Java is a fairly popular thing out of the Netflix folks, which basically liked RX enough that they ported it to Java. And so we've been working with them to create this overall site called reactivex.io. And so it documents basically every variant of RX there, and we're hoping that some of the documentation, like getting started, will be put there. They have some great things like marble diagrams, which is kind of a diagram to show you how each individual operator works in terms of when it yields values, if it yields values to the next stream down the line. So it allows you to kind of visualize what you're programming in a way. So all of that's really cool. I suggest you check it out at reactivex.io and let us hear what you think.
So one of the things that I've seen looking in the documentation for some of the many places there's documentation, I saw that it's also, I guess, advertised that the React RxJS works in the browser, but also works in Node. So not really a surprise there. But so what is the exact reason to use it in Node? Because it's decidedly different use cases for using something in the browser, say with React, or using it on the Node side. So what's the use case for putting it for using it in your Node backend?
Okay. Well, there's a number of good reasons. First, you've got event emitters, which are pretty much one of the core objects that you always use in Node. So the idea there is that you can turn event emitters into observable sequences based upon what you want to do. So you could literally say, if you have some sort of emitter, as it were, you can say, from event data.skip until connected.take until end, and then suddenly you have this data stream where you're listening to only from the data, and then once that end it'll only start when the connect happens, and it'll end when the end happens, and then all of those event handlers are automatically stripped away, and you don't need to worry about them. That is quite powerful. So there are a lot of people that are doing some really, really cool stuff there with that. We have interoperability with streams in a way, and the fact that it's kind of a one-way is that we have a pipe where we can pipe in an existing observable into a writable stream. And then we have you basically stream interoperability as well as callbacks, as it were, to be able to bind to callbacks. So you get that deterministic behavior of the callbacks and cleaning up. And but what's great about that is, once again, is that you can use many of our concurrency mechanisms, such as merging, concatenating together, doing a fork join, which is basically running them in parallel, and so forth. So you get a lot of those kinds of advantages as well. But not only that, but we have some really kind of deeply powerful SQL-ish operators as well that we have, such as the group bys and so forth, that are fairly interesting. So one of the examples that we have in there is I was writing a simple stock analysis application where we were taking some data from wherever it comes from. I just make it into an event emitter. But the idea there is that we can start to do stock trade analysis to see whether there are bumps in price of say 10%, either positive or negative, and then do something about it. So you can take a whole stream, group it by the stock ticker, do some buffering where you can compare the previous price to the current price and start to do some of those kinds of calculations. So once again, it's just this big toolbox that you can do a lot of really, really powerful things completely on the server side.
Are there examples of that on GitHub, like sample apps that deal with like real-time communication like that?
Well, they're
real-ish.
I probably need to create more of those. But real-time communicate. But the stock trade analysis, yes, that's there. It's called Stock Server. But in terms of real-time communication like a socket.io, I'm working on that because that's really one of the big steps that I wanted to take next, which is since I'm working with the Cortana folks, and to that extent, RX is kind of the backbone. It's RX.net and RxCPP and so forth. But at the same point, there's some really interesting things such as query expressions. So, for example, I can serialize basically my expression and run it somewhere else, whether it's in a web work or whether it's in a a different process altogether. I can serialize the entire tree, send it over the wire, and then the other side of RX can just pick it up and go with it. And that's really kind of the next step of where I want to be is that so you can start to write things like almost like a query provider for Postgres, for Mongo, for whatever you want to write it for, using the map and filter projections. And then suddenly you don't have to write any gnarly strings. It's just you're just writing natural functions, and then you can just serialize it or basically into a way of just querying things.
So does this mean we're working with a lot of immutable data, or how does it work with like a functional approach?
Well, we are a functional approach by default, meaning that. Right. That all of our streams are immutable by default, meaning whenever you call map or filter, etc., that you get a new stream and you're not modifying the existing stream. You're basically subscribing to the previous stream to create a new stream. So at the heart, we're kind of an object-oriented-ish functional approach, as it were.
And the performance, I would assume, is pretty good on that then.
Yeah, we obviously need to look at a few more things. That's my current release. Is I'm really going heads down on perf work, and I've gotten several operators to perform at better than say 2,000 more operations per second than the previous version. So I'm really kind of happy about that. I'm adding benchmark.js to make sure that I'm doing the right things there. There are a lot of other libraries that are coming out there that are really working less on the operators and more on perf. So it kind of behooves me to kind of do the same. Is to really make sure it's lean and mean, because, like, for example, Netflix and a lot of other people that are using it, they're using it on fairly constrained devices, as it were, whether it's your phone, a tablet, etc. And it just has to work, and it has to be performant, if that's such a word. And so the memory footprint has got to be low, etc., etc. So yeah, perf is a big thing right now. Like I said, I'm pretty happy with where we are. Obviously, there are a lot of changes and fixes that I can make in the near future, but that's also another key aspect of it. Is there versus using raw events. Yes, there's a little bit of overhead. Is it much? No.
Do you have like tests for performance in the repos, or do you have like do you plan on releasing like public perfs that people could go and take a look at and test themselves?
Yeah, right now I just have benchmarks against myself. So, for example, I take the previous version and the current version that I'm working with. So if you go into the tests folder, there's a perf folder in there, and that's where I'm using benchmark JS from John David Dalton, who's a really good friend of mine, and I actually got him hired here at Microsoft. And just working there very diligently on basically seeing every little piece of perf that I can squeeze out of all of these operators, such as method fusion, which I'm doing right now. So if you have two maps or two filters in a row, I can condense that into a single operation. And if you have a map and a filter, you can condense those into, or rather, you can, a map and a filter, you can condense that into a single operation as well. So it's all of those things that are fairly interesting, where you can really start to squeeze some perf out of.
So this is kind of a general question, but so we're talking about performance and optimization. When you have a library as complicated or as big as as RxJS, all the different flavors, how do you go about looking for certain areas that you can improve?
Well, the biggest area obviously is the core aspect of Rx is the schedulers. Well, that's the easiest part to start with is the schedulers, because the schedulers are basically controlling the how, what, and when. And then you look at the subscription level stuff as well and saying, are we doing the smart things about managing subscriptions as well? So you kind of start there. And then you start to look at some of the operators, such as flat map and so forth, that say, well, right now it's a map and a merge, but could I fuse those into a single thing and therefore save a little bit of call stack? So it's those kinds of analysis where I'm building, say, larger operators from smaller ones, and could I squeeze more performance out of it by just combining, just by fusing them into a single operation, and then looking at more functional approaches with closure scopes and chains scopes versus a more object-oriented approach using prototypes and prototype lookups. So those are kinds of the things that I'm doing right now, is I'm just kind of trying to trade off the balance between the two of them. And right now the functional approach is working very, very well, and as opposed to the more prototype-based lookup approaches, which is strange in its own way.
Nice. So doing a synchronous processing is obviously a lot faster than the promise approach of going through the event loop every time that you go.
Right.
But do you ever have any problems with recursion depth blowing out the stack?
You can always do dumb things. Yes. There are some people, like, for example, I was testing out the mutation observer. And I said, oh, why not? I'll just throw in 10,000 things and I'll recurse over them and see what happens, until my machine just absolutely locked up. But no, we specifically have a what we call the current thread operator, which is kind of dealing with more reentrant operations. So, for example, if you have sequences that inside of themselves generate more values, you're going to want to use that. So we automatically have a trampoline in there that tries to do its best to not blow out the stack, as it were. So we do a lot of those kinds of things. So if you look at a lot of our performance benchmarks, yeah, there are times when we don't do the where it is possible to blow out the stack, but we choose the right operator. We choose the right scheduler for the particular operation. For example, if you just want one value, we're just going to use the immediate scheduler, which says one and done, versus if we're doing coming from an array or something like that, where you're going to want to take a more recursive approach. That's when we use the current thread scheduler, so we can run it on the trampoline to make sure that we're not going to blow out the stack recursively.
Seems like a much better approach than some of the hacks I've seen with set timeout and things like that.
Oh yeah. You will never find any set timeouts or anything like that outside of our schedulers. And it's we took a very, very hard approach on that and said there are going to be no asynchronous leaks in terms of anything that we do. Everything that we have to do has to be in the right layer, as it were. So any set timeouts belongs in the scheduler. Anything that deals with composition, great, deal with in the observable directly. So yeah, we are very deterministic in our cleanup. There are no set timeout hacks, etc. We spent a lot of time whiteboarding this before we actually started putting code onto screen.
So a lot of people think of RX as just Microsoft, right? And I think you've done a great job of explaining that it's not. But
No,
some of the things
absolutely
that like when we talk about observables and schedulers, we're talking about, you've identified those, but the other part that we haven't really talked too much about is LINQ, LINQ operators, which when I think of LINQ, I do think of Microsoft.
Yeah, and so I actually, if you look at if you look at our GitHub site, I scrubbed any notion of LINQ from there because I'm trying to make it seem more along the lines that we're not, wholly tied to Microsoft. Yes, we do have aliases for select, where, etc., but we're encouraging more of the use of the JavaScript idioms such as map, filter, reduce, and for each in our code. So to me, that's I think that's a better approach. And then, we have great adoption through many customers that are using it, whether it's Netflix or any other people that are using it right now.
Yeah, I don't think it's a bad association. I do think, though, that it can be confusing where people look at it and they're like, LINQ operators, what are those?
Yeah, exactly.
Yeah.
And it is. So what we try to do is bring it more towards the JavaScript audience who already should know what the array extras are, but I guarantee most would in the JavaScript world just stick with for loops, quite honestly. I don't think they quite get the power of the array extras. But, well, actually that's not true, because a lot of people, instead of using the arrays extras, as it were, they're using underscore or lodash, which allows you to do a lot of those maps and filters and so forth. So those concepts easily transfer over to what we have.
One of my favorite parts of lodash is the chaining. Sorry about that. But it seems like a lot of the patterns that you're using are just this unidirectional flow, similar to Flux, right? Mm-hmm. So do you do a lot of the chaining of things, and then all at once at the end something gets put together?
Yep. Yeah, pretty much. Is basically you're chaining together through the subscriber for each method, basically. So you're taking the stream above you in the chain. You're listening to it, and then you're transforming it using a new observer and yielding it out via a new observable. So that's the grand scheme of things of how we chain things together, is that we create a new observable each and every time, listening to the previous and transforming it into a new one and shipping it down. And then at the very end, you can just call for each, which does nothing more than actually just generate over the values as they come through. So that's kind of how the chain ends, and what it gives you back is this subscription object, which is basically how it handles all of the deterministic cleanup that it needs to do.
Any thoughts on using transducers as part of that event flow?
Oh, absolutely. I mean, it's a great thing that the transducers have come out. So it's basically, if you take map, filters, and reduces, and you shove them pretty much into a single chain, I think there's a lot of wins to be had there. So to that end, I'm not writing my own transducers library, but if you conform to either transducers.js from James Long, or you use the Cognitex transducers-js, we do ship a transduce method, which basically, if you want to do the maps and the filters and the reduces, etc., you can just basically put the transducer right there in line with the code, and it just works.
That's awesome.
So basically, like I said, I don't want to reinvent promises. I don't want to reinvent transducers. I just want to build a bridge to what's existing out there.
Now, for those like myself who don't know what transducers are, can you guys explain that a little bit?
Sure. So traditionally, when we're dealing with querying data, we're going through and creating these intermediate data structures. So when you create a map, when you take an array, and then you call map, it's creating an intermediate version of an array. And then when you call filter, it creates another intermediate version of set array, and if you start throwing more of those kinds of operations in there, they're creating more intermediate arrays. Now, the idea behind transducers is that there is no intermediate array. between all of them is that they all kind of fuse into a single one, where it's kind of using this reducer pattern. Well, it's kind of an interesting thing. So it's kind of it's a take on the reducers that people have been doing for years, which is basically interjecting new functions into a reduced chain. And in this particular case, you're working more on transforming and reducing at the same time. So that there are no basic intermediate structures to be had. And you could do the same thing with Rx. We have a reduce function in there, obviously, and that you could start interjecting all of these other intermediate functions into it, so that you're basically hooking into the reduce loop, as it were, to do that. So it saves you, obviously, on a lot of performance, that you're not creating any intermediate structures and so forth, and it gives you a pretty rich functional query model that you're used to anyways.
Yeah, that sounds really useful, especially for the performance.
Absolutely. Yeah, I mean the intermediates, the intermediate arrays only really make sense if you're going to start passing them around, as different things. But if you're just doing one operation, all the way through, and you're never going to take any of those pieces out and hand them anywhere else, it doesn't make as much sense to have these intermediate structures. Which is why I'm doing method fusion in certain places as well, is to get rid of some of those intermediate steps.
Awesome. So I wanted to. I know we're starting to run a little bit short on time, but so we at the very beginning we talked about Microsoft and their kind of path to going open sourcing all of these different things. So we mentioned a little bit on why it's very cool, kind of why they did it. But I'm curious what your thoughts on why it's important that they did it, because all of us here are really big fans of open source, and I know this is trying not to sound like an exact copy of the question I asked before, but not why is it good now, but why it's important for the development community as a whole that Microsoft start to throw out some of these bigger projects.
Okay. Well, like I said, is traditionally in the Microsoft world, we would have these program managers that would just go out and beat the drum and say, "What do you folks need next?" And they would go to MVPs. They would open up and they would ask on Twitter or these insiders lists and so forth about what's really important to you folks. But that's such a small slice of the pie in terms of what people are really using your product for on a day-to-day basis. And the usability numbers that we get from Visual Studio and so forth aren't really good enough, or even NuGet package downloads aren't really good at saying what you actually use and what you don't use. And so to kind of shorten that loop, open source is just so tremendously valuable. You basically just opening the kimono and just saying, here's everything that we have. Let us know what you really do want what you really do want us to focus on, and guess what? If you really feel that passionate about it, you can contribute to making that happen, which that empowers the community. I would say that traditionally in the Microsoft sphere at least, is the open source community was a lot weaker than its Java, JavaScript, Ruby, Python, so forth counterparts, because they were kind of waiting for that blessed thing from the Church of Microsoft, as it were. If we're talking about the cathedral versus the bazaar here, is they're looking for that officially blessed thing. Now, yes, there are a lot of great open source projects in the Microsoft space, but I'm just saying in terms of sheer numbers, it's not as much as the Java and Ruby and Python communities, if we're being honest about it. But what's great is the fact that it's now going to kind of spur the open source community around Microsoft, in that that people are going to start seeing a lot more of the things being open, seeing a lot of the possibilities with the Roslyn compiler or with C#6 or with some of the libraries that we're releasing, that they're like, well, I can build upon that now because I now understand how it works. So it's about shortening that feedback cycle, but it's also about empowering the open source community as well, as to get involved with what we do. And what's a great side benefit of that, and it's actually also a key thing of what we're trying to do now, is make sure that our software works on pretty much every platform. Making sure that, like, for example, RX can work on iOS through Xamarin, to making sure that it works on Android. Any number of those things is very, very important to us, in the fact that we want, obviously, to have our software everywhere.
I'm really excited for Fsharp being on all platforms.
Yeah, absolutely. Yeah, I mean, it's been, everyone was just like, well, I just want it, the JVM version. I'm like, no. Once you get .NET Core anywhere and everywhere, you don't even need Xamarin. It's just as accessible as the JVM. Why not? And then people can start building all the tools around that they want to do.
Yeah, it seems like Microsoft has made a total 360 with a lot of this, or 180, if you will.
Yes.
Where,
yeah.
It's 360, nice. But
we're going in the same direction, but we just took a long time to get there.
Yes, it was all about the journey.
Exactly.
But what I mean by that is even the stuff that you don't have in open source, right? Mm-hmm. Like the Internet Explorer source code, right? That what's happening on modern.ie, even before Spartan was announced, status.modern.ie, all the virtual machines that you can download for the Mac to test on different versions of Windows. It's really important to involve the community and get that feedback, and I think you guys are doing a great job with that.
Yeah, total hats off to the IE team for doing what they did. They actually launched, it was really kind of cool at JSConf last year, where they turned officially a few things green as to being supported on IE while they were there, and they're like, oh yeah, and if you like status.modern.ie, hey, we're on GitHub, so we take pull requests. That to me was just like, wow, this is the IE team that we were talking about here.
Yeah.
So that to me was mind-boggling. And then you have things like Spartan, where we're trying to distance ourselves from having to ship all the compatibility. Well, we still have to ship the compatibility wedges and so forth to support IE8 and so forth, but at the same point, it allows us to iterate on a less creaky code base, as it were, than the old tried HTML.
So Jacob Rossi had written an article on Smashing Magazine about the release of Spartan, and one of the things he said in there, I was like, wow, I couldn't believe Microsoft was doing was anyone who has like Windows 7.1 and up, for the first year of release for the next version of Windows, they're giving free upgrades.
That's right. Yep.
That's fantastic. And what that's going to do, for those who don't know, is now you're going to have browsers that are self-updating.
Yep.
So once you do that, now you're going to have evergreen browsers on, everywhere. So that's going to really push the web forward. So
it's just
some great stuff there.
We still have to deal with the enterprises and those who try to prevent that, so their corporate apps their terrible corporate apps can still continue to work, even though they're still using attach events from IE8 and only work on IE8. But that's why we included things like enterprise mode, and it works fantastically well in terms of it solved 99.99% of the problems that people would have. But yes, the evergreen aspect of it is great in the fact that we as a company can now innovate a lot faster and ship a lot faster, just like the Chrome and the Firefox folks can.
Yeah, I just wanted to touch back on this wonderful topic we have. I went to the reactivex.io website, and that thing has got some amazing knowledge and resources. So I wanted to make sure that we got that out there for those who listen, that we had that link, because this Reactive X is a wonderful website.
Yeah, it really is, and like I said, the what we have is we have the general, documentation, and we're like, well, here's the core set of things that we would call RX, and here are all what they're called variants on all the different languages, and here's pretty much how they should operate in terms of a map does this, a merge does this, a filter does this, and it gives you that visual representation, which is really, really kind of cool. And then it goes directly to link to those particular libraries in general. So it's basically this whole community, and I'll try and tie it up with a little bit of a story, in the fact that Netflix, when they started out a couple of years ago to looking at their complete stack, is that each different platform that they had to support, and each different runtime had its own asynchronous models and so forth. But when they standardized on RX for pretty much Groovy, Scala, Clojure, Java, .NET, and JavaScript, suddenly it allowed their developers to speak one language, so that they could literally pick up a JavaScript programmer, throw them into Java, or take a Java programmer and throw them into JavaScript, because they're speaking the same language of the reactive extensions. So therefore, it made it a lot easier for them to kind of just speak the same language, as it were, even though they're on completely different languages.
Well, you guys are doing a great job. I want to thank you for coming on. And is there anything else you want to say to listeners, and how they can contribute to the projects,
Yep.
and what we can do for you guys?
Yeah. The biggest ask I always have of people is, what they're doing with it is always key to me, because there are so many people using it in such mind-boggling ways that I've never expected it to see. Like, for example, last week Angus Kroll started to mess around with RX and was doing a bouncing ball simulation. It was awesome. And I'm like, those kinds of official kind of examples I would love to see more of, and that I can link to them or put them into our repository, because people always ask, well, why would I use RX? Well, here's a whole slew of demos that show exactly why you do that. Our documentation, obviously we have pretty decent documentation, but that always could be improved. And especially with comparisons to other other popular libraries out there, in certain cases I give more of a reason why you should use RX over those given libraries, but more to the point, why what are kind of the concept mapping differences between the two are fairly useful as well. And of course, things like commonly things that you run into problem-wise in terms of trying to solve via streams, if we need to introduce a new operator or not, that's also very helpful. And of course, obviously, perf is key. If people want to chip in on that, I would love to hear some suggestions. But I think we have a fairly solid footing. It's just that we have lots of places to grow, and even though that we're in our fifth year of existence as a library, we're just really starting to notice now where it's just totally picking up. That's things like Bauer use it, and any number of these kinds of things where it's just amazing the sheer number of downloads that it gets per month. It's amazing. It's great.
That's awesome. So people can go to the GitHub, they can submit pull requests, issues, and all that. And if anybody has any questions or anything like that, what's the best way to get in contact with you? Do you have a Twitter or email?
File issues. We have a invite-only Slack room. So if they want to To get invited to that, they can ping at Paul C. Betts on Twitter. And that basically hooks you into the entire RX community that actually spends a good amount of their time daily on Slack, like I do. Because IRC and stuff like that just isn't as flexible as to having a whole place where all of the RX community can just kind of live, and that's the beauty of Slack, I think. So that's definitely a great place to be as well. And yes, we do have a mailing list, but we also have our Twitter feed at Reactive X is also a great way to get in contact with us. We frequently tweet about what we're doing, as well as highlight community projects and highlight issues that people have. So that's also another great way to get in touch with us.
Very cool. All right, so we're going to wrap it up. Thanks
Great.
again for coming. Appreciate it.
Yeah, thank you. Thank you so much.
Thank you.
Not a problem.